Welcome everyone to the Agentic AI for Science Hackathon 2025 at the Johns Hopkins University. The motivation behind this hackathon is to explore and evaluate AI agents for scientific tasks. What you'll gain is hands-on experience with cutting-edge AI tool, opportunity to win an Amazon gift card, and work on a research publication, and of course collaborate with this team of experts. My name is Kamal Chaudhary. I'm an assistant professor at Material Science and Engineering and ECE with DSAI affiliation. I'm leading this hackathon, but with me, we have co-organizers Christopher Stiles, Yu Sun, Chinmay Maheswari, Lakshi Shi, Pioring Liu, and also I would like to thank event coordinators Katie Watt, Brad Rano, and Shelly Pagano. This is the outline for the hackathon. We'll start with a welcome remark from Dean. Then we'll go to the introduction of the hackathon, discussing the challenges, and then we'll get our hands dirty during the hands-on session. And so let's get to it.
When we talk about human creativity, we speak about it in a positive sense. When we talk about AI hallucinating, we speak about it in a pejorative sense because we say, well, it's made something up that's not real. Maybe it's being imaginative. So that's just an example of not to have preconceived notions, but to really expand the way you think about things as you build the systems that you're going to build today. Very excited for this. I think learning by doing is the only way to advance the field. And so I'm really glad that this is happening. I'm glad that the organizers have organized this. I want to thank all the organizers for their effort, and have a good time. Enjoy yourselves.
Thank you. So thanks again to the Dean. One more time, please thank him for taking the time and giving this remark. And then we will moving on. Thank you. I'll see you later. Yeah. So moving on, we will continue with the agenda. And let's see. So first is introduction. So I think also the Dean mentioned standard AI may fall short in science. For example, hallucination, what he mentioned, where the AI models can provide incorrect results with high confidence. Sycophancy, so where LLMs try to be over positive praise. So you're doing great. This is the way to do it. And we have seen some news in the New York Times and so on, how it has deluded people to think they are doing the best thing. But actually, that's not the good case. So sycophancy. Many commercial models are proprietary. So there are black box. We don't know where our inputs are going in, where it's stored. They may not be reproducible. So science wants reproducible responses. If you ask a question today, tomorrow it may not be giving the same response. And of course, although there have been significant advances, especially for domain sciences, still there are a lot of room for improvement for this kind of tools. So our solution would be to have agentic AI frameworks. So these agents can be developed using RAG, tool calling, MCP, A2A. We'll not discuss all of that today. In this particular hackathon, we'll be discussing about tool calling and fine-tuning and other agentic AI. We'll refer to other hackathons. So what is generative AI versus agentic AI? So you can consider generative AI where it produces content such as text, images, data for given input, right? You can consider it as a brain, okay? What is agentic AI? I consider it as agent plus brain plus hand. So it can actually take action. So it's based on a goal. It connects with API, databases, run calculation, and so on, which only generative AI cannot do that. One of the best articles that I have seen so far for the introductory level is from this OpenAI called A Practical Guide to the Building Agents. This is a nice PDF article. Actually, when I was starting a couple of years ago in this field, I stumbled upon this PDF. It was quite useful. So feel free to check it out. And yeah, we'll try to use agentic AI for especially for science, because scientific domains are so huge that developing and training model on entirety of that task is extremely difficult. So this API connection database search is quite useful. Let me start with a very simple example. Suppose I ask, how's the weather in Baltimore or something, or New York City, sure. So if I ask this, remember these large language models have been trained on past data set. So they will not know what's happening right now. So it says, I don't have real access, real time access to the current weather, so I won't be able to answer. But now let me turn on the web search on. Okay, you see the blue icon on? Now I hit search in atomgpt.org. Now it searches the web, and now it will give me the responses. What is the weather right now? Well, at that time when I run the prompt. So it connected some of the APIs with search in the Google, and there are other tools like Jarvis and so on, which we'll discuss. There are many tools we can integrate, a kind of short circuit this LLM models, and that's the idea of agentic AI. There are 2 million brains or LLMs on a repository called Hugging Face. So Hugging Face is a repository where most of these AI models are hosted. There are 2 million of them. Which one do you use? And this is why there's a huge thrust nowadays of design benchmarks. So if you're a researcher back 10 years ago or 20 years ago, you'd have a problem in big data or AI model development. But right now, you'll see there are a lot of benchmarking. Like a ChatGPT beat a lawyer in an exam or a high school student in an exam, and so on, an undergrad student and so on. So this is the idea of benchmarking. Unless you test it, you don't know whether this particular model is designed for your particular task. So this is the motivation of AtomGPT when we developed. It's actually quite recent. It was published recently this year in the IMI journal in a paper called ChatGPT Material Explorer. And because ChatGPT Material Explorer is a proprietary model, we developed an open source version of it at atomgpt.org. I think you can join with your GHU email, but also I would recommend using Gmail or GitHub. Just click on this, and what's different from other models is specialized for scientific domains like searching for materials, machine learning, protein structure design, X-ray diffraction. These are all open source model. This is linked with arXiv. So if you want to search a paper and so on, you might have seen that most of these previous generation, at least the LLMs, they used to make up papers names and titles and so on. Yeah. Yeah. So it's not trained. It's a LLM model, but it's not fine-tuned on a data set. It's just connecting to the outside sources. Yeah, for a particular response. So suppose I ask to write a script for lamps. It can write something which looks very nice, but may not work. What we will try to do, which is not there, one of my PhD students trying to do, it will check it internally, running the script, and then give it to you. Yeah. So previously, what happens if you have this kind of model, you write if else, if lamps do this, if wasps do this, and all these things, right? But the good thing about agentic AI, it can automatically figure out which tool to connect. And that's the advantage of it. This is all based on great question, is all based on open source models. Right now, we have 8 of these. And most importantly, in my opinion, as a researcher, we don't want our data set to be in ChatGPT or so on. We don't want to give all our SS social security numbers and whatnot, all our private emails. So this is why we strictly follow this policy that every month this chatbot data is automatically deleted. So you can use it privately, that's fine. And you can also have an option to delete your chat, of course, right, in the box. It also comes with the model context protocol, function calling, we'll discuss. Currently, we have about 2,000 users and worldwide, mostly in the US, in China and India. And there are a lot of examples on the AtomGPT Labs/AG API GitHub page for this. Now, let me start with another simple example of benchmarking. How many are in strawberry? Okay, this is actually very famous in LLM modeling. So if I go to AtomGPT, select OSS model, there are other models, but Llama Maverick model, Gemma model, and click search. Now it will give you a response from 3 different models. Now you will see the GPT OSS model from OpenAI gives 3, from Llama 2, and Gemma from Google gives 3. Now, is the way this tokenization works sometimes very difficult for these small problems to be solved by these LLMs. I want to point out, although much improved version right now, like GPT-5 can crack it very easily, but I want to point out there are several limitations. And as a researcher, you should always benchmark on some simple task where that model is suitable for your task before you blindly trust the results. That's the idea of benchmarking. So that's another feature in AtomGPT, which you cannot probably do in other chatbots. You can compare different outputs from different models. Not just open source model, we'll soon hopefully have some quota-based system for the GPT-5 and Claude and other models as well. So API tool that you can use today is, of course, this. Of course, for solving the hackathon, you can use whatever you like. There's no restriction. But I would encourage to use our open source model, the AtomGPT model, which has at least 8 models right now. DeepSeek, Google, Moonshot AI, Meta from 2 versions, OpenAI. So the Meta has one with multi-modal model with vision and text, and one with text only. GPT OSS model was recently released by OpenAI. It's one of the most powerful models out there, in my opinion. Quen model is also there, and we'll be integrating more and more models there. We'll be using the function calling or tool calling in the exercise. There's no limit to the how many questions you can ask. Privacy is important, and it comes with the REST API. Now, before I go in details, have all of you made an account in AtomGPT yet? Because it's required for the hackathon. If you have any issues, we have our co-organizer. They'll be happy to help you. So I'll show you a demo how to make an account. You go to the AtomGPT with Gmail or whatever, then go to settings, and then go to account, then API key, create a new key, and copy this key, okay? And save the thing, save this box. So this is a key that will be used for interacting the AtomGPT through programmatically way, okay? You don't have to go to the website. So get your API key, and don't share API key with outside world, with anyone. And accidentally, if you do it, refresh it. You can see there's a refresh button. You can always refresh it, the API key, but there's only one API key for each user. Okay, we did that. All right. So this is kind of a Jupyter notebook, but hosted on Google Cloud called Google Colab. And we'll be using this during our hackathon. We'll be providing you the link to the to the Google Colab very soon. But the idea is you can install softwares, run the task, save the task, save as a GitHub gist. I'll show you how to do that. And then that link of the gist you'll be submitting in the Google form. Do not email me. Okay, I get 100 email every day. Do not email me. Just in the Google Forms, you want to put the link to the GitHub gist and send it to so that all the reviewers of that hackathon will review and decide who is the winner or who did best. Okay, there will be question like how many tasks did you solve, something like, and the responses from the different code that you developed. So let me show you how it look like. You go to this Google Colab, you'll see you can install softwares like OpenAI agents and AG API, AtomGPT API. Click on this, run anyway. So you're installing the software right now. And then the API you got from the account from the website, you just want to put it there, paste it there. You can see. Of course, I have refreshed this key, so don't use this key. If you ask very simple question, what's the capital of US? So now you don't have to go to the website. Now you can interact in the code as well. Now let me show you an example of how to build agents with the weather app. So here is an example of interacting with OpenAI agent from the OpenAI software. Say it again.
Could you zoom in a little?
Zoom in. Okay, let's see if I can do that. Does that help?
Much better.
Oh, okay, sure. Where was I? No. Oops. Now I don't know. Okay, I was here, and let me zoom in like this. Okay, so yeah, here we are specifying OpenAI GPT OSS model, but you can specify other model as well. In this particular section, we'll be showing you how to use or enforce the model to give a particular weather. Remember, it does not know the weather, but I'm enforcing it. The weather in any city is 62 Fahrenheit and 45-degree humidity. I'm enforcing it. So anytime you ask the model, now I have specified and given this thing called get weather, this tool called get weather function. Now you'll see if I ask what's the weather in New York City, it will give you 45 humidity, 62 temperature, and so on, right? So this is a way of customizing the output of a GPT model or any AI model, LLM model, right? Oops, didn't want to do that. Yeah, we'll give it. We'll give it one. Yeah, we'll give it 1 second. Yeah. Yeah. So we'll be learning about the function calling in the later section of this hackathon, maybe a few months from now. We'll also show a very new development called MCP, Model Context Protocol, in A2A from Google, and that is a part of our motivation for you to join the next hackathon. Okay? So part 2, the challenges. We'll be building the weather query app. So if you go to the atomgpt.org and ask a question like this, location, Baltimore, and so on, and provide your API key, it will give you the real-time weather. This is just a demo, okay? So we'll also search for materials in silicon carbide. These are the tasks you have to do. Write a custom function. Silicon and carbon in the entire data set in Jarvis DFT. Search for papers for magnesium boride in the archive data set. There'll be a specific math challenges. And for this, I would recommend you to use ChatGPT and Claude and Gemini because these are extremely difficult challenges. Even at least when we tried a few days ago, it did not work. So, and then finally, if you can solve all of these, and if you have ideas to build new agents, you will be most definitely contributing to our paper that we are working on. So this not limited to this. You can also build new agents. In the notebook, again, this is the link you want. You can take a photo or something, and it will lead you to the GitHub page of the Agentic AI4Science GitHub page. And from there is a section called Google Colab, and you can click this, and that will give you the Google Colab. I'll stop. I will pause here for a second. Let us all get on the same page. If you have any issues, this is the time to speak. Any issue getting to the website, GitHub, let me know. It should be this page, okay? And here you'll see the open in Colab. If you click this, it leads you to this Google Colab notebook. All right? I'm assuming there are no trouble getting there. So, and these are the 5 tasks. That's right. I can just, yeah. And then I'm going to demo you how does it work on the website, but you have to do the same task with tool calling that we showed. That's the difference, okay? Something like tool calling has been implemented in the AtomGPT website internally, but I'm asking you to develop an open source version of it yourself. So here, let me show you a demo. I give the AtomGPT website weather, location, Baltimore. I give API key and hit enter. Now it shows me do the pretty print, and then you'll see the Baltimore, what's the temperature, and so on. Next example is searching for materials like silicon and carbon in Jarvis DFT dataset. It's a database of about 100,000 materials. If you search for silicon and carbon and provide API key, hit enter, you can see it gives you like ID, chemical formula, space group, formation energy, and a bunch of other. You have to report how many materials you found using your tool calling. Now, another example is search for all the papers called on magnesium boride in archive. You give the API key, hit search, enter. So you can see the title, ID, summary, authors, when was it published, and so on. And you can make a tool like this. These are just few tools. There are many other tools in atomgpt.org. And the idea is, at least in my research group, whoever graduates, they have to have at least one tool added there. So it will be a fruitful kind of PhD resource that people can use later as well, right? So as a hackathon, you have to solve at least these challenges. And if you can come up with more tools, fantastic. Most importantly, save your GitHub gist. So once you are done with making the tool, you can go to File, Save as a GitHub gist. It will make a new URL for you, okay? If I, for example, do this, it will make a new URL. And this is the URL you want to paste in the Google form, which is also given below the Google, in the Google Colab notebook, if you scroll down, there's a thing called Google Form. You can just paste this link there, and that's all. No need to share a lot of data. Or if you encounter any issue, so maybe we have about 100 or so people in the hackathon, maybe the website is slow. If you are not able to solve the problem because of that, you can provide that as a comment, okay? So we'll consider that later. We can consider that as well. All right, so this is how you save the gist. This is how the submission look like. So there's the same GitHub link with the, also have Google form. You have to answer how many tasks did you complete. Please be honest. Don't worry if you can get at least 2 tasks and 2 of them correctly and the fastest, you are the winner, okay? Doesn't have to have all of them correct. But whatever you do, to be honest and should be complete. Or at least even if you did not complete, you tried, you can save that also as a GitHub gist. That's fine. Also, if you want to be considered to be a co-author of the paper we are working on this hackathon, feel free to select yes or no accordingly. And being part of this, I just want to emphasize, you agree that it's okay with you. If not, don't submit it, okay? If you don't agree that your data may be used or we might be considering you for a potential paper, if you do not agree, that's fine. But I encourage you to be part of this because, you know, this is kind of great thing to be a part of the university crowd and we can do this kind of studies. So how you'll be judged? First, the 100 points, you'll have technical implementation, how novel you are. You have to have some docstring. Please have docstring. Please use a reasonable variable. Don't use L in your variable, all these kind of things. And then reproducible. So just check before you submit, it works, right? In the Google Colab. The good thing about Google Colab is it actually stores the output. So we can also check it from there. Be nice to each other. Don't copy. So these are some of the code of conducts. Do not plagiarize from other people. Do not disrupt other people, and so on. You guys are, I think, pretty awesome on this. So post-hackathon, in week 1, we will announce the winner. We'll take some time to evaluate all the notebooks. And then in a month or so, we will reach out to you if you have participated, at least giving the Google link, the Google GitHub gist link. If you have provided that, then we'll ask you if you want to be part of the paper and so on. And then paper publication conference, and you'll have opportunity to work with me or other co-organizers. This is also a good way to meet your future PhD advisor or research advisor in a way. So with that, I would like to thank you. And this is the same GitHub link. And if you have any questions, I'm happy to answer.